Alright, we should be live for WorldCon office hours. Alright, let's just make sure. I'm going to make sure that the stream is going through. So I'm going to go on to the links we provide on Jupiter Hub. Make sure I right click on that link and I do see myself. Let's see. And yeah, I do see myself. So alright, it's currently streaming. Welcome guys to WorldCon office hours. October 26th, the start of week 5, so halfway through the program. All right, let's see who is with us today for office hours. I see Akina, Omadara, Maxim, Tom is here, Malcolm, Paulo is here, Shakiba is here. Hello, everyone. RDX is here. Soon is here. I see Araf is here. Hello, guys. Welcome to WorldCon office hours. Happy to see you guys joining in as well. All right. I see Joseph is here. Hello, Joseph. Hope you guys have a good start of your week. One thing I want to mention, and we'll probably send an email about this, but in the U.S., we are going to end daylight savings next Sunday. We're going to end daylight savings in the U.S. next Sunday. So how that affects you is that we are going to adjust the office hour times to be the same in the U.S. So in other words, I'm based in the East Coast, so the Monday, Wednesday office hours start at 8:30, and we will adjust the UTC time so that it still occurs at 8:30 U.S. time. And I know that across the world, some different nations, some nations do daylight savings, some don't. Some observe it at a different time, so that might affect what time office hours start where you are based. So we will make an adjustment for office hours starting next week. We will probably send an email out with those details that it might affect when you can come and attend. But nonetheless, with that said, let's see who else is with us today. Shubham is here, Gita is here, Cyrus is here. I see that Ana Belen is here. Hello, guys. Welcome to Office Hours. On my agenda today, I do want to talk about Pickle, Python Pickle package. And I want to talk about this thing here, Dunder Main Dunder. Someone brought it up about a week ago. I haven't had time to talk about it, but I do want to talk about that. Someone has mentioned, can you talk about the final half of the challenge of Q2? And that was talked about in one of the past office hours. I'm not sure which one. Probably the one that deals with if you look at past office hours, the one with the thumbnail that says PWQ2 or PWQ3, that should have our discussion of the final half of the challenge of Q2. If there is time today, and if it's a bit slow, I can go ahead and recover that group by field function. That's the challenge for Q2. All right, guys, let me know additional topics you want me to throw on the board. My current plan is to talk about Pickle and this thing that someone mentioned they saw of Dunder Main Dunder equals Dunder name Dunder. Modify this right here. All right, let's see other things people bringing up. Saying, I noticed some introductory questions on the DW mini project. Do we ignore these? Let me take a look at what you mean by that. Let me know, Tom, what you mean by those introductory questions. Not quite sure what you mean by that. If it's not part of the grader, then it's not required. Paulo is saying, how do we add autocomplete features in Jupyter Notebook? NB extension. So there should be there should be code completion automatically on your Jupyter notebooks. For example, if I go to Office Hours, create a new notebook, Python 3. And I rename this to, let's say, Office Hours October 26, 2020. there should be some autocomplete. For example, if I say my list 0, 1, 2, and 3, and I start M and I hit tab, then I see my list of options, MY tab, that autocompletes to my list. So there should already be autocomplete features in Jupyter Notebook already. It should be built in, at least the one we provide. But without hitting tab. Okay, you want to have it autocomplete without hitting tab. Let's see. You want it to, so in other words, you want to say MY and then pause for a bit and it to populate a set of options before you hit tab. Is that what you're looking for, Paulo? Going back to what Tom said, there's an IN. Yes. There's the IN mini project is repeated. It's located in two places. It's located in two places. Just you need to solve for one of them. It is repeated. Doesn't matter. It's just there as a duplicate. Okay. This is called Hinterland. Okay. I'm unfamiliar with that. I'm unfamiliar with that. And I guess the answer is there probably isn't, at least for these pods, you may not be able to introduce that feature. But yeah, I guess there is. I would avoid installing things on your pod because you might mess up a configuration on your pod that might mess things up. People have done in the past where things get messed up. I have to go and clean it up. So I would say that we might prevent you guys from installing additional things to this environment because we want to make sure everyone has the same environment that works exactly how we expect it to work. But you're more than welcome to download this on your personal computer, install Jupyter Notebook, and install those extensions to the environment to have those additional auto-completion features. Okay. Someone is saying my computer's Jupyter Notebook doesn't have autocomplete. So I believe the tab autocomplete should be a base feature, but you might want to look at maybe that wasn't installed. I would do something very simple like I did here. My list equals 1, 2, 3. Hit my Y and hit tab and see if that autocompletes. Yeah, all right, no problem. Glad I was able to answer that. All right. Okay. All right, I see Malcolm is typing something, so let me know. All right, so I see Malcolm saying if I do list dir append, so dir is a way to see all the attributes of something. All right, so that's what you did there. And it doesn't, however, tell me how to use the method. It doesn't tell you how to use the method, and what you need to do to tell you how to use a method is if I do Shift Tab, then I get a message saying how to use information about how to use that method or function. Hit Shift Tab again, I get an extended message field, and if I hit Shift Tab 4 times in a row, then I get this pop-up. So that's what you need to do. So you start writing out. So I can say something like my list, and let me run this cell there. So I my list append. Shift Tab, I get a little nice message. Shift Tab twice, I get an extended message. However, there's no extension here. And hit Shift Tab 4 times, and this pop-up appears. And that's how you can look up easily the documentation for some function, for some class, for some method in Jupyter Notebook. I see test max item is missing from office hours, I think. Okay, maybe I can revisit that. Put that right there. Test max item. All right, Malcolm, do let me know if that answered your question about looking up the documentation. I can also look it up by ending it with a question mark and hitting Shift Enter, and that also does the same. This is very great because one of the things that I stress here is that it's very difficult to memorize how all these packages work. Right? That's not really our job, to memorize how all these packages work. Of course, we want to make sure we understand how they work at some basic level and have a familiarity with using those packages. But very common is no problem that when you're working on something that you look up the documentation on how to do something. So that gives you an easy way you can look up the documentation for some utility for your application, for your project. Someone is saying is how to kind of import the grader into the locally installed on my computer. The grader only works on our pod. The grader only works on our pod because it's set up to communicate with our grader server. In fact, if you're ever wondering how our grader works, I'll give you a quick snapshot on how our grader works. So this is your process, your Python process right here. In fact, maybe we can at some point replicate how the grader works. And here is our grader server. And when you do the grader.score, what you send is the question and your answer. And what your process does, it calls on this grader server saying, hey, can you give me a test set to evaluate this question? And it sends that test set back to you. The grader call that you made takes your function, takes the test set, runs your function with the test set. And then it gets that answer that's derived. It passes it to the grader server and saying, this is my answer that I received. Can you tell me what my score is? The grader evaluates your answer, sends it back for it to be displayed about what your score was. At the same time, or right afterwards, it writes to a database. It writes to an SQL database. With your score, with your submission. So that's in short how the grader works. I see Desmond's here. Hello, Desmond. So unfortunately, the grader won't work on your personal computer because it's not hooked up to this grader server to record answers on an SQL database. So it's not going to work out, unfortunately. Okay. All right, so I'm going to go ahead and start with the agenda for today. I answered a couple of questions. Let's talk about pickle. So I'm not sure how pickling occurred when I say pickling in terms of the culinary approach, but pickling is a great way to preserve fruits and vegetables. I have a cucumber. A cucumber probably only lasts maybe a week. I'm guessing a week or 2 weeks. I can, of course, put into the refrigerator. That can maybe last a month, but after a while, it will tend to rot and go. It tends to rot. It goes bad. So I'm guessing that our ancestors figured out that if I were to take this pickle and I were to put it into a vat of spices and salt and let the spices and salt infuse into this cucumber, that the resulting product, the resulting food I get is going to last longer than a fresh cucumber. Somehow they discovered that. I don't know, right? It's always marveled me how our ancestors discovered that certain mushrooms are good to eat, certain mushrooms you shouldn't eat, that cooking meat is better for you. I don't know how our ancestors discovered these things, how they figured it out. I'm glad they did because we're definitely benefiting from their discoveries and the mistakes they've made. But nonetheless, we figured out that pickling is a great way to preserve food. So if we were to take this analogy and think about it in terms of Python, maybe you have a Python process. You have a Python script, a Jupyter notebook or whatever, and this very complicated process, it doesn't have to be complicated, But in this process, you want to preserve a set of Python objects. When you open up a notebook, when you open up a Python session, you create objects, and these objects are stored in your computer's memory. And if you end that Python session, then those objects are lost. For example, here I have a notebook. I create my list, and I can say my list append -1. And then I'm going to do kernel, restart and clear output, and I say my list, and I get a name error. So my list isn't there anymore because I've shut down this process. So what I want to do is I want to have a way where I can preserve the Python objects I have in my current session. Because what I want to do is later on, I might want to resurrect or retrieve the contents of those Python objects. So I need a way to preserve my Python objects. An application of this idea of preserving Python objects, and we will see this if you go on to Unit 2, is you might have a Python script or a Python process that creates a trained ML model. So this process creates a trained machine learning model. A trained machine learning model in order to make predictions. And this training process, the time it takes to train the model, isn't trivial. In other words, it doesn't take a second or a few seconds to train it. It might take up to an hour, maybe even just a couple of minutes to train. And what you want to do is you want to use this trained ML model in a web application. In other words, you have a web application that exists right here. I'll put this in a cloud because it exists on the web. And you have users. And these users are going to send information to your web application. And it takes the user input. It runs the machine learning model to make a prediction, and it sends back the prediction back to the user. And this here is running a Python. There's a Python web application running here. I'll draw that right there. In fact, I might be running something called Flask, which we can talk about in a week or two. All right, so this Flask application, this web application, has to make use of this trained ML model. But you don't want to have to retrain the model every time you want to use it. You want to be able to load up the preserved trained machine learning model so that it's ready to go for predictions. So to recap, you have a separate process that creates a trained machine learning model that makes predictions. And then you want to have a separate process that relies on this trained machine learning model. But you want to be able to preserve this model right here, so it's ready to be used for your web application. So we have the way to preserve this. And one such way is using Pickle. So let's try out to use Pickle. Let's use Pickle. So here I create my list. So there it is, my list. And then I'm going to preserve my list. So I'm going to import the Pickle module, part of the Python standard library. So it's already good to go for every Python installation. And I say with open, and I say mylist.pkl. No need for a file extension. File extensions are arbitrary, but I'm going to use a file extension that makes sense, like pkl, which I know is perhaps a Pickle file. And I'm going to write to this in binary mode. I'm going to create a binary file. I want to write to this file as f. And I say pickle.dump, the object I want to preserve, followed by the file handle. So we run this cell here. And what we've done is we've created a pickle file on our computer. So there it is. There is that pickle file that we've created. And now if I do kernel, restart and clear output, in fact, maybe what I'll do is I'll go and create a new notebook. New notebook right here. And rename this, and I'll call this Office Hours October 26, Part 2. And now I want to retrieve my list, and it's preserved to disk. So what I do is I import pickle, and I say with open, and the name of the pickle file, which I called mylist.pkl. And since I want to read it, I say R, and since it's a binary file, I say B as F. But instead of saying pickle.dump, I say pickle.load. So I say pickle.load F, and I assign this to a variable. So this pickle.load function will take this file handle, take that pickle file, and basically recreate the object. So you have a recreation of the object that you had before. And now I can say my list, and there is my list. Notice I was able to recreate that object. Let me know if there are questions so far about pickle. Let me take a look at the chat in the meantime. All right, so someone is saying, can you please help how to contribute to open source projects? All right, so here, what I'm going to do is someone's asking about open source projects. In my aim is that perhaps at the beginning of week 7 or the end of week 6, what I plan to do is for us to work on some project together. Some project together that will tie some of the things we've seen so far in lecture, but also learn additional tools that aren't covered in the core curriculum. And this project we're going to host openly. We're going to have this as an open source project. So basically our aim here is to create our own open source project. But the whole point behind that is for us to get familiar with the tools that are needed to contribute to open source projects. And maybe if we have time, maybe I can look at some open source projects that we can go ahead and contribute to. But I think the prereq for that is for us to work on a project so we can solidify the tools and the knowledge and understanding how to contribute to open source projects. So we'll put this here for future agendas. All right, I see a couple of follow-ups. Someone is saying I see someone's asking about some about weekly periodicity, perhaps logic used for the fractions, the one where matplot has been introduced. I'll have to take a look at that. I see someone is saying, can we pickle deep learning models in what do we store weights in architecture? So yeah, so you could pickle deep learning models. In fact, if you use something like TensorFlow, it has its own binary mode for preserving those deep learning models. It's not exactly pickle, but it has its own variant of how to preserve those deep learning models. And then, so if we use TensorFlow, you can do model.save basically. It's going to preserve the model, so a separate process can use that model. So the answer is you could use pickle, but I would suggest you use what is provided in the framework. So TensorFlow has their own, PyTorch probably has its own. You can also perhaps save them as maybe a JSON that contains details about the architecture and the weights, so it's interoperable. You can use for a different process, but yes, the answer is yes, you can. In short, someone is saying, is Desmond, can we use Django to host the ML models? Yes, you can. You can use Django to host the ML models. In fact, if I have, yes, you can. In fact, we'll see that in Unit 2. But you can use Django or Flask to host those ML models. I haven't worked with Django. I've worked only with Flask, but you can do so with Django. All right, someone is asking here is, can you ask questions about past lectures? You can bring up topics that haven't previously been discussed thoroughly here in office hours. If you ask something that has been discussed extensively in past office hours, what I would do is I would point you to the video of the recorded office hours where we had that discussion. And the whole point there is making sure that we're always talking about fresh content in office hours. But that's why we do record these. That's why we do maintain this playlist, so that if you bring up a question, I say this was discussed extensively in the past, I can point you to that video so you can take a look at it. So hopefully that's a sort of like a fair compromise, but do post your question, Esther, so we know what you have a question on. All right, I'm going to go ahead and move on talking about pickle. So here we pickled a list, and that's a pretty simple Python object. It's just a list. What are other things we can pickle? We can pickle quite a few number of things. For example, I can pickle something like a function. My function accepts a and b and returns a plus b. I can pickle a class. I can say my object, or maybe pet. We talked about pets previously, so why not do that? Object init self age and name won't extend it, just a very simple class there. We can even have we can have dictionaries, we can have whatever. We can preserve quite a few things. So for example, I can say something like data. Oh yeah, I can say something like data. And in this list, I can have my list. I can have, let's see, what else can I have? I can have my function. Let me just make sure I run this out here. I have my function. I can have the pet class. And then I can say something like with open data.pkl, write binary mode as f, and say something like pickle.load f. Sorry, dump. So I'm going to preserve that, data and f. So now I've dumped a list that contains a list, a function, and a class. So when I go to this process here, a different Python process, it can be the same one, but let's do it with a new one. I can say with open I think I call it data pkl, read binary mode as f, and I say data equals pickle.load of f. I see. I kind of ignore what I just said because I should really use still for that. But anyways, I can say with open right here, data pkl, read binary mode as f. I can say pickle.load of f and say data retrieved. And now I can say data retrieved. Index 0 is my list. Index 1 is my function. So now I can say, since data retrieved 1 is my function, then I can say 1 and 2. I get 3. I can say something like pet equals data retrieved 2, and say Snoopy is its name and 70 years old, And now I can say pet.age and pet. I have it flipped around. It should be age and then name. Right? Age and then name. Let me just fix that. And name. So I was able to preserve a little more complicated objects. All right, let me take a look at things that are going on in the chat. Okay, so someone is, how do we convert it to a Python library so it can be downloaded as anywhere via pip? All right, we can talk. I do plan to talk about Python packaging at a later date. In terms of our project we plan to build, but that is something I do want to talk about. All right, let's see a couple of things that are going on in the chat. Do let me know if there's any follow-ups of using Pickle here. So someone has a function that makes time series stationary, def stationary. I want to apply it to n data frames, which needs me to write multiple lines like df a stationary, 10 similar. How can I look to do this using a single line or similar? Okay, I can put that here on the agenda. Pandas time series stationary. All right, we can put that right there. All right, any questions so far with Pickle? Any questions so far about Pickle? It's a great way to preserve an arbitrary Python objects. What's basically happening is that when we pickle something, we are writing down to disk a set of instructions on how to recreate that object, so that a separate process or the same process can recreate that object without having to create it from scratch. Now there's some problems with Pickle, and one of the problems is that Pickle is very powerful. For example, I was able to preserve a function, and it's not so clear. It's not so clear if someone hands you a Pickle file. I say, hey, here's a Pickle file. You should use it. It contains an ML model for you to use. Trust me. Well, you can't necessarily read. It's not a plain text file. In other words, if I try to read my Pickle file, I'm trying to read it. I get something that resembles. I can kind of make sense of it, but it's not readable. It's not human readable. So if someone gives me a Pickle file, I have to trust that it's going to do what they claim it to do. So what if that ML model that someone gives me and says, hey, this ML model, try it out, use it. Here's a Pickle file, use it for your application. Maybe that isn't an ML model. Maybe what it is a function that, I don't know, imports OS, the Python module OS that lets me do operating system level tasks, and maybe deletes things on my computer. Maybe it installs things on my computer. So the problem with Pickle is that it's very powerful, so people can be malicious. People can introduce things that in the Pickle file that I don't want it to do. Delete things in my directory, install things, mess things up. So because of that, I like to say that Pickle is best for internal consumption, or for a single user application, or not single user application, but for an application that you create, that you will be using. And you shouldn't be downloading Pickle files off the internet. If someone does give you a Pickle file, it has to come from a trusted source, perhaps within your organization, within your team, Hopefully you can trust your teammates, but only internally into your team, only internally in your organization. Because of the flexibility of Python. The flexibility of Pickle. Someone is saying, is there a way of documenting the objects? Do you mean, is there a way to have some information tied to the object so you know where it came from and blah, blah, blah? Like where it came from, things about it. Is that what you're kind of asking, Tom? Let me know. Okay, apply a function n times and get n data frames. Yeah, I can take a look at that. Yes, pickle files are binary, which is a problem. I try to read it. I try to make out. I can understand some things, but it's ultimately a binary file, which is a problem. I see Frederick is here. Hello, Frederick. I think I do recall you from the past time. Welcome to Office Hours, Frederick. All right, and going back to Tom's question about documenting the pickle file, what is best practice is that in our project that we're going to use to create a pickle file, what we should do is we should have a Python file that was used to create the pickle file so that we can take a look at it, we can show people that we trust or that trust us, and they know exactly how that pickle file was recreated, how that pickle file was created. And this is great because if I need to recreate that pickle file, then I can just run that file again. So for example, what I'm going to show you here is right here is a project. It's for academic purposes. You probably shouldn't use it for production. But in here is a Python project that what it does, it creates a trained machine learning model to predict fraud, a fraud detection model. And it uses that fraud detection model to run a Flask application so that people can input fields and be able to give the person back a prediction whether that transaction is fraud. And if we look at it, we try to make sense of it. Let's go into model. Here, there's a Python file called fraud model. I'm going to blow this up so it's a little easier to read as we transmit. And there's a function called create model. And there's a function called preserve model. And in here, anytime someone wants to, so we clearly see how the pickle file, and here I use a Python package called dill. I don't use pickle, I'm using dill. Dill is a third-party package that's very similar like pickle, but it's supposed to be slightly better because it's able to preserve a wider range of objects. So in fact, people like to use dill when they want to preserve a trained ML model. It works pretty much the same way. Pretty much the same way. Here we're using dill instead. And it's supposed to be a joke because dill pickles, I guess that's the joke. But anyways, going back to Tom's question is that here we've documented how this pickle file is created. We know exactly how it's created. And then we have a separate file called app.py, and this is a Python file that creates the web application. And in there, it uses the trained ML model. So there it is. It loads up. It calls a deploy model, which is a function to read the pickle file, in this case the dill file. So going back to Tom's question to answer it properly is it's really up to you to document the creation of that pickle or dill file via a Python file. So it's very clear to someone how that pickle file was created. And what I do here is now if I were to publicly host this project, I probably shouldn't host the pickle file or the dill file. But what I do provide is how to create that file. In fact, we can talk about make files later, but in there is a rule to create the pickle file, create that dill, that trained Emma model. Okay, so let me know if there's any follow-ups about pickle. I will scratch that from there. And there is, I'm looking at, let me go and look at the chat here. Okay. Raghurash, I see your question, and I'm taking notes because maybe I can best prepare that for the next office hours, but I am taking notes of your question so I can properly answer it. Maybe I would best frame it to be a little more general, so answer your question, but be a little more general so it has wide applications. Someone's saying, can you give us a link of the GitHub repo you shared? Yes, I can do. I can share this project right there. Take a look at it. In fact, it's got a nice set of instructions on how you can make this run on your personal computer. And that's ultimately what we're trying to do in the later half of this course, is how can we take and develop our own Python project that's used technologies like what we've seen in lecture, learn some new tools like GitHub, working the command line, version control via Git, deployment, Python environments, all those things that aren't part of lecture, but we can definitely talk about and learn in office hours, and then build a project. Maybe not something as snazzy as, I don't really consider this snazzy, but something that makes ML predictions, but something you can take as a framework, as a basis for your applications, for your specific projects, to understand how we can contribute to an open source project. In fact, we'll basically be creating our own open source project. So we will get to that. Okay. Follow-ups behind pickle before we go on to dunder main dunder equals dunder main dunder. It's a great segue because we see this dunder name dunder equals dunder main dunder. Okay. So one of the things that I've been teaching you guys is the idea of dry. Do not repeat yourself. The other thing that have emphasized, but haven't emphasized too much, is the idea of separation of concerns. We can, let's say we're trying to work on a project that does two things, two basic things. It creates a trained machine learning model. I know this is unit 1, so we don't go into what machine learning is, but in short, we want to learn how to predict or classify transactions as fraudulent or not fraudulent. And we can train a ML model to do this classification. And you'll learn how to do that in Unit 2. But just for this argument's sake, we have a Python. In our project, we want to create a trained ML model. And the second thing we broadly do is we host a web application to use this trained machine learning model. So broadly speaking, doing two things. And we can put all this basically in a single Python file. We can do this. We can perhaps force it. It's all in a single Python file. But this is not going to lead to the idea of readability. Remember that Python emphasizes readability. And in general, it's great that our code that we create, the projects we create, are readable. We want other people to take what we've done, understand what we are doing, and also we want to help our future selves. All right? At the very least, if no one else is going to work on your project, or if you don't care about other people, at the very least, you should care about your future self. So readability very helps in that idea. So what we want to do is we want to separate out what we do into separate Python files. So broadly speaking, in this application here, we should have two files. We should have a file that creates the Emma model and a file that uses that Emma model and hosts it in a web application. Separation of concerns. So we have one file that does this, another file does that. Let me take a look at the chat. Why do we need to include this kind of compression file, pickle, in our web application? The compression, yes, notice there we are using a compression. There is just to reduce the file size. That is simply just to reduce the file size. It's not required, but it'd be nice if I can reduce the file size so it's easier to send via the web. And that we're using a free tier service, or I used a free tier service to host this application, and the free tier caps you about the file sizes for your project. So it was very important that I do some sort of compression to reduce the file size. Okay. So now, notice I have this separate file. Won't get into all of it, but notice it's separate into functions. There's doc strings that tell you what those functions do. And then we have this weird thing, or people might find weird, where we say if name equals main. And if that is the case, then we run these two commands. Looks like we create the file, we create the model, right? We create model, create this model, and then we take that object and we call the preserve model. Or create that preserve model. So what exactly is going on here with if name equals main? Well, first of all, double underscore, it's hard to say double underscore. So the shorthand for double underscore is dunder. So double, dunder, double underscore dunder. And this goes into if a Python file is the main file we run. So in other words, I will create a new, I'm going to say a text file, by the way. I'm going to rename this and say, I'm going to say this, call this process 1, py. Not a very useful name, but process 1. And this process has a function called Fahrenheit to Celsius. It accepts an argument called degC and returns the conversion of that degree Celsius into Fahrenheit, which I believe is, that should be the equation. And I say, and I want to do some conversion, so I try it out. So I do far to Celsius, and I say 0, print that, and that should be 32 degrees Fahrenheit, and I call this function, in fact, I named it backwards, right? I'm converting Celsius to Fahrenheit. So Celsius to Fahrenheit. Sorry about that. And I say far to Celsius. And I probably misspelled Celsius. I think that's something else. Print that. Celsius 32. Let's do 100. 100 degrees Celsius is 212 Fahrenheit. So create a Python file to do this. And let's say, and if I go here and I go to new terminal, let's run this in the command line. So I open up a terminal. What I'm going to do is we can talk about working command line at a different time. Let's go into, let's type in ls to see where we are. Let's change our directory into data course. So cd data course, type in ls, and let's change our directory into office hours. So cd office hours. Looks like perhaps I have a mistake there. Let's see. I think that's fine. We'll see what happens. And I say Python process 1. Name error, because I forgot to change the name. Okay. And I still have a syntax error, so syntax error, end of line, so probably missed out something, probably missed out a parenthesis, which I did right there. I fixed that. Made a mistake there, no problem. That's how we bounce from those mistakes. Let's run Python process 1, and I get my two answers, 32 and 212. So in short, what I've done so far is I've created a Python process, a Python function, Python file that defines a function and uses that function twice. Pretty straightforward. Right, and I can run it here in the command line, Python process 1, I get my two answers. Now, let's say I want to make use of this function in this file. It's a very simple function that you can perhaps write it out again, but let's keep to the principle of dry and separation of concerns. Maybe this file had other functions like Fahrenheit to Celsius. And this returns the inverse of that, minus 32, then multiplying by 5/9. And now, if I go back to my Jupyter Notebook, I want to make use of those functions. So what I could do is I can say, and perhaps it's better if I rename this to something that makes sense, temp conversions. Right? That's what it does, temperature conversions. Conversions, I think I spelled it correctly. Temp conversions. And now I want to make use of these functions. Yeah, they're simple. I can recreate them, but let's stick to dry. Imagine if they were a little more complicated, and we don't have to write it out. So in order for me to make use of those functions, what I'm going to do is I'm going to say from that Python file, from temp conversions, import the function I need. And let's say I need the Celsius to Fahrenheit function. And I run this, and that works out. And then I can say Celsius to Fahrenheit, and I say, let's say 0. 32. I can say 20 degrees Celsius, 68 degrees. And let's say I want to encapsulate this as a separate Python file. So in other words, I go here, new, text file. And maybe what I have here is maybe I have in this new Python file, I say temps equals 0, 10. Maybe I can say temps range from 0 to, let's say, 40, a step size of 2. And for temp and temps, I am calling this Celsius to Fahrenheit function. I say temp there. Let's go ahead and rename this. Rename this to reading conversions. Reading data conversions. Let's say, how about that? Data conversions. A simple process that's going to import that function in this file here and basically iterate through that list or that iterable and just, let's say, print out those values. Pretty simple process. So let's make use of it. Let's go back to the command line and I say Python and I called it data conversion. Data conversion. Now I ran that. Now it's a little hard to tell, and let me go adjust this here. I'm going to say the first temperature I convert is 10 degrees Celsius. I said 0 before, but I'm going to choose 10, and then the reason will be apparent. And let me go ahead and run that. I'm going to do Control L, that clears that output. Control L clears the output. Let's run the process again. Python data conversion. Notice the first two answers, 32 and 212. Wait, where did that come from? You might be wondering, where did those come from? In fact, I started off with 10. In fact, I can do a little message saying print starting the conversion. Go back here, do Control L to clear that output. And notice I have 32, 212, and then starting the conversion. What is going on? When I use this function, why is it printing out these two things? Well, the reason why is because they were included in this temperature conversions file. So basically what is happening is when I say from temp conversions import Celsius to Fahrenheit, what Python is doing, it is running all the code in this file, which is define these two functions and ran those two functions here. But I don't want this to happen. So tomorrow we will pick it up. We'll talk about how we can prevent this here from executing when I import this file, and we'll see how it makes sense with the dunder main dunder. I know there has to be some setup here because we're seeing some new things, but we'll pick it up tomorrow for office hours. Ragaraj, I made a note of what you're asking for, so we can perhaps talk about that tomorrow in office hours as well. Answer your specific question, but also generalize it so it has greater applicability. But with that said, guys, take care. And what I'll also do is I'll start making a list of additional skills that I do plan to talk about and lecture on once we've getting to our project. So I do plan to outline a set of skills that are required for it and start tackling via mini lectures. All right, let's see. All right, guys.